Kubernetes is the bedrock of the modern web. It was designed specifically to host standard web applications, which means it excels at keeping containerized microservices running in a predictable, always-on, perfectly synchronized state. Then came the era of artificial intelligence. Machine learning models do not behave like predictable web servers, and their computing life cycles break the rules these traditional environments rely on. An AI workload might demand maximum GPU capacity for a massive 3-hour tining run and then abruptly drop to zero. Alternatively, it might require a rigid, scheduled pipeline for preparing data, followed by a continuous, around-the-clock stream for live inferencing. When you force those highly variable, chaotic compute demands into an architecture built exclusively for static web traffic, you create severe bottlenecks. The system buckles under the strain. To bypass these bottlenecks, different departments within a company usually start building their own separate workarounds. The operation splinters. You end up with web teams forcing their deployments through Kubernetes, data scientists retreating to legacy schedulers like Slurm to handle their GPUs, and data engineers scripting entirely separate pipelines using Airflow. Organizations end up buying redundant hardware for each of these isolated silos. This creates massive visibility gaps where the systems fail to communicate with one another. Imagine trying to troubleshoot a critical failure at 2 a.m. Your engineers have to hunt through 4 totally different logging systems and authentication protocols just to trace the broken link. Operational fragmentation, rather than raw computing power or model capability, stalls enterprise AI at scale. The solution is a unified approach known as flexible orchestration. Instead of favoring one workload, this framework treats short-lived batch jobs and continuous always-on services as equal citizens. It collapses those fragmented silos. A single DevOps team deploys a web microservice and spins up GPU training from the exact same interface. Because the orchestrator has a unified view of the hardware, it handles the heavy lifting automatically. It schedules resources dynamically and instantly self-heals failed jobs. Data scientists no longer file tickets and wait days for IT to provision a cluster. They request the compute they need, run their experiments, and release the hardware back in minutes. Managing artificial intelligence transitions from a bespoke IT crisis into a scalable, routine business operation. With a highly efficient, unsiloed infrastructure, the next step is determining how AI actually navigates it. This is where Treecapital's nVen model comes in. nVen operates as a central reasoning engine, sitting atop this orchestration layer to govern your enterprise. In the LangChain ecosystem, the central nVen model routes commands outward to break down problems. At the VectorDB node, RAG checks proprietary databases to ground decisions in facts. On the agents node, nVen delegates tasks to specialized agents and APIs to execute actions. In this configuration, the AI actively orchestrates the very infrastructure hosting it. Giving an AI this level of access naturally raises a critical concern for any enterprise: the risk of sensitive, proprietary data leaking out through a public API. Notice the thick concrete layers labeled private cloud in this sovereign stack schematic. The entire unified system runs completely on-premise. Up top, security locks represent the protection of telemetry and model weights, satisfying privacy mandates like HIPAA while ensuring absolute data ownership. Production-ready enterprise AI functions as a sovereign digital asset under your total control, moving past the limitations of rented, multi-tenant services. This chart outlines the financial impact of sovereign AI operations. Descending steps track total cost of ownership reduction drivers. By optimizing workload batching and deploying 4-bit quantized models, organizations push costs down step by step, landing on a 90% cost reduction for batch processing. Because these models are highly compressed and lightweight, they offer complete deployment flexibility. They run just as efficiently on massive centralized server racks as they do locally on mobile devices at the network edge. You get a native, frictionless connection between your traditional DevOps teams, your machine learning automation, and your advanced agentic workflows, all without the trap of vendor lock-in. The organizations that succeed in this next computing cycle will be the ones that stop duct-taping modern machine learning models to legacy web infrastructure. They will build sovereign, flexible intelligence engines that scale seamlessly on their own terms.